Ladies and gentlemen, please take your seats. The panel will start briefly. I have a little announcement. There was a change in the program. The Minister for Research and Innovation, Mr. Buduja, that couldn't attend the first panel, will come in the next panel at 2 o'clock. So we'll hear his intervention then. I will give the floor to Mr. Hoștiu.
Thank you. So we're going to start this panel regarding the ethics of emerging biotechnologies. Now, hopefully today we're going to touch some pretty important areas in this field. We have a pretty diverse area of discussions, from genetics to AI. The first presentation will come from Ms. Eva Bartnik, which is member of the WHO Expert Advisory Committee on Developing Global Standards for Governance and Oversight for Human Genome Editing. And she will give a presentation about genomic medicine, precision medicine and genetic modification.
If I could have the first slide, please. And I think I'll have to stand. Okay, I will talk briefly about genome editing, and you cannot talk about genome editing without mentioning the two people who invented it, Emmanuel Charpentier and Jennifer Doudna. But I'm going to go a little bit on a tangent. This is the cover of an absolutely non-scientific magazine, The Economist, from 2015, showing how a genome-edited baby could be made. All the genes, I'm a geneticist, are inappropriate for editing, but let's leave that. I'm going to say the following thing. A lot of very wise bodies have looked at genome editing, and we have a whole panel of attitudes to genome editing, starting from one that it is absolutely unnecessary on the scale of fetuses or embryos, because if you do not accept pre-implantation diagnosis, there's no great reason to accept genome editing, which is much more of an intervention. But I'm just showing some things. One of the first things was the report of the International Bioethics Committee on updating its reflection on the human genome and human rights, and there a moratorium was proposed. It was in 2015. Moratoria are something which don't always make sense because you don't really know what you're waiting for. And there are some more things here. And the thing on the left, if you like futurology, do read it. Jamie Metzel was a fellow member of the WHO committee. He's a futurologist, and he shows a future where essentially everyone will be editing. So, very briefly, I think we may have many applications of genome editing, as was mentioned, in agriculture, in medical care, but I don't really think that the future of humanity lies in modifying embryos for various technical and for various ethical reasons, and I think the ethical reasons will be addressed more by my fellow panelists. But I would like to say a few words about something which is a very, very important thing in modern medical biotechnology, which is precision medicine, which was mentioned by the Pfizer vice director. Mainly, we think of addressing diseases by addressing exactly the problem that is occurring in a given patient. And there are sort of two names for it. Personalized was used from the late 70s, and interestingly enough, in papers it's no longer explained from about 2008, so everyone knows what it is. But much more now we use precision medicine, and sometimes it's the 4P: predictive, personalized, preventive, and participatory. The participatory part is difficult in the sense explaining to someone the basics of genetics and what the intervention will be could be quite complicated. But I like the term precision medicine more than I like the term personalized, because quite a lot of precision medicine is not just for one person. We have various drugs, Gleevec, which I'll talk more about, and Herceptin, which is for one form of breast cancer, and millions of people with a problem with cholesterol taking statins. This is personalized, but it's not biotechnology, it's lower technology. And this is one of the most beautiful examples in my field, where this is quite an old paper from 12 years ago. You had a pair of non-identical twins, a boy and a girl, who, when their genomes were sequenced, were found to have two defects in synthesis of neurotransmitters. So when they got the two neurotransmitters, and this is something that, the presentation, if anyone wants it, please write to me, I can send it, or it's also the organizers have it. But in any case, this is something which is coming more and more. To find the cause of a disease, you can sequence the genome. And this was a very good example. Another example of precision medicine, which is quite incredible, is a disease which is called spinal muscular atrophy, which is a rare disease. One person in 10,000 has it. And there is a drug for it, and I'm not going to give you I have a tendency to go into molecular genetics because this is what I normally teach. But in any case, this is an extremely beautiful example of the use of basic science. Sometimes I think what people who work in basic science are told by the people who give the funds that we should do something practical. In a way we do, not always directly. To put things very briefly, you have a gene which is mutated. Two copies are mutated. The first one, the sorry, I always go too fast. You have a gene which doesn't work because it has a mutation. Next to it, you have a gene which doesn't work because for some reason, the way the RNA is synthesized makes it unstable and no protein is formed. If you stabilize the RNA, you get treatment for the disease. So you have a drug called nusinersen, and here we go into the problems of precision medicine. The cost of the drug is $125,000 per year in the United States, so it's almost three quarters of $1,000,000 per year. And there are also gene therapy treatments which cost about $2 million. And you may have heard a couple of years ago, because there was not enough, and there's still not enough of this wonder treatment available, what was happening was that the company which provided this organized a lottery. And a lottery for sick kids is something which is extremely shocking. On the other hand, what do you do if you don't have enough of it? Another drug which has been around for many, many years is something for treating chronic myelogenous leukemia. In chronic myelogenous leukemia, what you get is a very strange thing. Two nice normal chromosomes exchange bits, and you get a protein which causes cancer. And since the 90s, there has been a precision drug for this, which essentially has made normal life expectation for the patients who normally died very shortly. And the thing is that we are looking for more and more precision drugs in various fields. We have gene therapy, very successful for some diseases, very, very expensive. And we have also some very interesting drugs for cancer, for various kinds of cancers, which are not as successful sometimes as Gleevec, but we're getting there. We also are getting immunotherapy. One of the few diseases which is relatively common, which already has a way of being treated, is sickle cell anemia. One person in 50 in Africa is a carrier of the disease, and 1 in 500 in the United States. And I'm not going to show you pictures of people who have been treated. The treatment works. The problem we have is simply this. Do we go into this hoping it will be cheaper? Do we try to make it cheaper? How? Because it has to be individualized. Or do we look at this that was written in 2010, that progress in medicine, I'm going to read this, has been almost exclusively due to a completely different trend in personalization. Interventions that have been addressed to all: clean air, water, effective sewage systems, pure food, programs of population-wide vaccination. I think we should also devote more attention to prevention, because screening of newborns for various diseases has saved many, many lives and many, well, health. I mean, children who are diagnosed with phenylketonuria at birth develop normally. If not, they have intellectual disability. people who are overweight are at risk of many, many diseases, and a successful drug for overweight, Ozempic, has only turned up now. The previous attempts were very, very unsuccessful and had many side effects. So we are really at the beginning of a revolution in technologies. However, which way this revolution will go is something that has to be decided. And there's one more thing that I have to say. I very well remember the previous revolution, the genetically modified organism ones. The effect of that is that 60% in Europe believe that there's no DNA in anything that isn't genetically modified. And in one state in the United States, I think Oregon, but I'm not quite sure, 80% of the people think that things that have DNA on it should have a label. So I should also be labeled if we do it that way. And it is extremely important not only to talk about the future among scientists and politicians, but also the general public. Otherwise, the rejection or acceptance of whatever we plan for the future will not be rational. It will be based on fear. Thank you.
Thank you. Now, if there are some questions from the public. Okay. If not, I have one. Where do you see in the future that genetic modifications will be more prevalent? Because you said that it won't happen in the embryo. So before pre-implantation or somatic modification?
Somatic is something that we all accept. I mean, gene therapy has been with us for a while, and I think the discussions on whether we should or should not, I mean, it's the same thing. Should we treat a patient? Here, it's more the ethics of doing something which can only be applied to a few people. Though I heard a lecture online by Jennifer Doudna. They're working on making it cheaper. So perhaps, I mean, I still remember the tales about expensive antibiotics and people not being able to afford them. So this may happen. I think the modification of embryos is utopia. Especially it's utopia for most of the traits that people would like to modify. To have the perfect baby, you would have to modify hundreds of genes. It won't work.
Yes, but you know, there were some experiments in China with HIV.
Yes, but first of all, he shouldn't have done it, because in order to make the baby safe from their father's virus, all you had to do in vitro was to wash the sperm, centrifuge it down, and resuspend it. So, no. And the second thing is it did not work. We know nothing about the third girl who was born later, because she was already in prison, and the Chinese government didn't make any reports on it. But the two that he modified, in one it was only one gene, and the other one it was two modifications. None of them was the modification that has been proved to work in preventing infection by the virus. So it was botched, it was unethical, and should not have been done.
Thank you. Any other questions?
I have a question. Hello, Juana Dima, EUSAGE, European Sustainable Agriculture through Genome Editing. So I have a question to you, whether you see any difference in the discourse between the GMOs, I think the scientists lost these discussions in the 80s, early 90s. Do you see any difference between the GMOs and new genomic techniques right now, whether there is any more acceptance within the customers, and also how do you see the communication with the public, with the customers on this new genomic techniques? As for example, in Poland, at least, the consumers are pretty skeptical on these technologies, and we can see a lot of non-GMOs labels on butter, milk, cheese, or even food cans for animals.
I think the last 3 years are a difficult time to evaluate anything, because people are focused on other things. Poland is not a good example of anything, because somehow we have quite a lot of people who make a lot of noise which doesn't make sense, but who other people follow. But what I can say is that the attempts to reach out to the public, to discuss things with various groups, not in my country, but in general, the WHO, various things organized by the European Parliament and so on, they are trying to have opinion from the public. What I can say as a science popularizer for many, many years, the problem is that the ones who come are either the ones who know and are interested and want to learn more, or the ones who are against. It's extremely difficult to get anyone interested in something they're not interested in. I'm sorry for the circularity, but it is really a problem. But there is much of a difference, because I think we botched the GMOs in the 70s and 80s. We sort of, this is a beautiful technique, accept it, and there were some discussions, but very, very little. The funny thing is that the expression playing God surfaced in the 80s, and it's surfacing now again.
Thank you. Any other questions? If not, I thank you again, Ms. Bartnik. And our next speaker will be Mr. Emilian Mihailov, who is the director of the Research Center of Applied Ethics and an associate professor at the Faculty of Philosophy from the University of Bucharest.
Thank you. Thank you first for inviting me. I'm so happy that we get to debate these topics in Romanian context and have such esteemed professors to present their perspective. So one thing that I want to say from the outset is I really like the focus on the conference, which is on resilience. But for me, who I'm dealing I'm studying and researching the topic of biomoral enhancement and enhancement technologies in general, and I'm analyzing this for almost 10 years. I'm really happy to see this again in the Romanian context. But if you look at what is the concept, as a philosopher, I really like to look at how we understand our concepts and how we use our concept. So for example, the main theme of the conference, the concept of resilience. So what do we mean by resilience is often in this context of post-pandemic is used like we are now managing or starting to manage stuff. But if you think of, for example, at the one end, treatment, the idea of treating something, and at the other end, the idea of improving something. Resilience, if has this dimension of forward-looking, is more to the continuum of improving things rather than treating. So I guess you are all open to the idea of what we want to do with emerging technologies is not just treating diseases or correcting diseases, but also improve capacities and improve our disposition to be resilient. So this is my, if you want, the conceptual framework that I will delve into. And one thing I'm very happy to say is that we, when we talk about resilience, we ask this question whether we are fit for the future, whether our institutions, whether our psychologies, whether our ideas are prepared to face the challenges of the future. This is a very famous book which we translated into Romanian by two Oxford philosophers, Unfit for the Future. So we have to ask ourselves whether we use science with the purpose of becoming more adaptable and more fit for future challenges. Now, we can see different levels of control where we use emerging technologies. You have the biological level of control, you have cybernetic level of control, and more recently has become computational control, in which you see ChatGPT becoming very, very adept at solving all sorts of demands from the part of the humans, either like text editing, or I just read this morning an example in which a lawyer asked ChatGPT to give him the text for a pleading in front of the court. So anyway, I'm expecting like in a few years this will become highly, highly sophisticated. 2 days ago, we had a conference at the Faculty of Philosophy. A very important researcher from Oxford presented something, and then we all agreed in principle, sound very, very plausible. And afterwards, he deceived us and told me, like, the first draft of this was written by ChatGPT. And we're like, wow, this is better than when I was an undergraduate. I mean, it writes better than me when I was a student. So that was a little bit disappointing because I thought I was much better when I was undergraduate, but it seems that that's not so. Anyway, we should expect an increase in what can we manipulate and control at all sorts of levels. Now, this is a very hot topic. Professor, our previous speakers talked about this, but what I want to point out is even with gene editing, there are talks that it will not have only applications about treating diseases, but also about improving capacities. So there will be a question whether you are open to such kind of applications. Like motivation, just to give you two examples, motivation to learn has a genetic basis, not only genetic basis, but it has a genetic part. Intelligence also has a genetic part. So you can see through these examples potential applications for resilience and improvement. Okay, now I just want to present you now some results of a study we did with my colleagues from University of Granada, Switzerland, and Oxford. So we looked at, let's see what factors influence people's acceptance of emerging technologies. Like, in what context do they accept, and in what context they are so reluctant, for example, to accept gene editing for improving motivation to learn. So before presenting the results, just want to take a survey here, and I want to ask you if you are in principle open to using emerging technologies to improve people's capacities, dispositions. Just raise the hand if you are in principle open to these kinds of applications. Okay. Let's see who is reluctant. I'm not saying that denies or has a strong stance, but who is reluctant? Okay, just want to say that in the concept of raising the hand, the elbow has to be okay. So I have at least two people who are reluctant. I'm not saying that you are opposed, but you have second thoughts. That's good, because it's not very well to have an echo chamber in which we all agree. Okay, let me show you what results we got in experiment 1. We described to participants an agent who takes a smart pill. A smart pill is usually referred to medicine like modafinil. Modafinil has been developed in the context of treating sleeping disorders, but to healthy individuals it has effects on attention, concentration, memory, so they do very well. Now, we described an agent who takes a smart pill either in activities like playing music, cognitive abilities, school, education. So we described all sorts of contexts. Now, what we noticed is that what really attracted participants' attention was not that whether it was a legal rule against it, because then we've made a follow-up study in which we said, suppose it is legally to take such smart pills. The most important factor that attracted their attention was the fact of fairness. Whether people have equal access, whether people have equal opportunity to such kinds of improvements. Okay. Now, when we saw that fairness seems like such a big factor, we decided let's make a further experiment in which we decided to see whether people's moral values influence judgments of attributing skill to individuals. So for example, we described in a scenario in which an agent takes a smart pill. We stipulate that through his own efforts, and so it's a conjunction, and through the effect of the pill, they are performing better than their previous activities. So again, we stipulated that through their own efforts and the contribution of the smart pill, they are doing better. What we discovered is that judging the skill of the individual is not independent from people's moral values. What do I say by this? So for example, if you, here you see different values, loyalty, sanctity, liberty, fairness, harm. So for example, if you care much about harm, we discovered that you don't say or you don't judge negatively an individual, and you would say, well, he exercised his skill, but at the same time, he benefited from the pill. But here's the most striking result that we found. If you are very attached to the value of fairness, you will tend to devalue the efforts of the agent. And you will say, no, 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 even if he contributed by his own efforts, I suspect that the pill did all the work. This is a very interesting result because it shows that we are heavily influenced by our moral judgments, by our moral values, when we assess people's performance. This is not a neutral assessment. This is what we discovered. So, in the end, what I think is, you said that we are living a technological revolution. Where we will go, we'll have to see. So just to give you a tentative answer to that question. The fundamental issue with emerging technologies is not that they are unnatural or that they are repugnant because we have a sort of ideal vision of what nature versus technology means. The most important issue that will face us in the future in implementing emerging technologies in our societies is the issue of fairness. People are very activated by whether they will have access, by whether they will have the opportunity to use such kind of technologies. So I guess for the future we should be very careful in having discussions about fairness and assuring people that the end point of this is to make sure that most or maybe a lot of people will have access to this emerging technology. So thank you.
Thank you. Are there any questions? Okay. Of course.
I think one of the main problems is the fuzzy line between treatment and enhancement. I mean, if you have someone has muscular dystrophy and you get his muscles back to normal, it's treatment. If you get them 10% more, it's enhancement. But if you put it this way, it already gives the fuzziness of the borderline. The thing is that I do not think the things that you mentioned, which do have a genetic component, would be enhanceable by genetic means, simply because most of these things depend on very, very many genes. And each individual one gives very little. This doesn't mean that they won't discover one tomorrow, which puts up your IQ by 10, but there is no such thing so far.
Thank you. Indeed, when we talk about enhancement, we have to see what is the threshold above which we want to go. For example, regarding cognitive enhancement, even studying is a form of cognitive enhancement. So we have to see what threshold do we use when actually debating the ethical implications of these technologies. And regarding fairness, again, even if nowadays these biotechnologies are expensive, because many are, if we look in the past, many technologies that are in common use today were very expensive. So we have to always look forward, even if now they are expensive and we see them as unfair. We do not have to. We have to also take into consideration the fact that their cost would go lower in time, and their addressability will be much higher.
Yeah, I think those are very, very good questions, and I think if you look at indeed a lot of examples which show pretty expensive technologies, after a decade or so they become accessible. And I guess that's what we want with these emerging technologies, to gradually to make them, to speed up the accessibility. And one important thing about thresholds, indeed, there are many ways of enhancement. School is an enhancement. Institutions, political democracy is an institution which enhances people's well-being. And if you look at writing is a technology. Writing it's quite recently in the history of humanity. And there were people at the beginning when writing was developed that challenged and said that writing is bad for us because it destroys our memory, and defended oral culture. So I guess similarly we are in a similar position in which we need to discuss what kind of means are more appealing or not.
Exactly. Thank you. Any other questions?
I have many now. You talk about fairness, but usually fairness comes from the fact that they want the technology, but they want it to be available to everyone. So coming back to your first question, from your studies, did you see a more positive response or a more negative one, or reluctant?
So that's a good comment, because I didn't have the time to present you, but we also did an experiment in which we want to see whether, depending on the context, people will stress more the value of fairness. So what we discovered is that in context of competition, in which there's a zero-sum interaction, a zero-sum means that in order for me to win, you need to lose. This is like in Olympics. So for me to get the gold medal, you need to get the silver medal. In these kinds of interactions, people are really upset when fairness standards are not upheld. Whereas in non-competitive context, in which if we cooperate, we both have something to gain, people are more acceptable. So indeed, as I told you, it depends on the context. In this particular aspect, competitive versus non-competitive contexts, we will see different answers.
If I could add something on the concept of the naturalness that you touched upon, and also the fairness. So about the naturalness and technologies versus technologies, I think we as human beings, we very much like the concept of naturalness. But if we talk, for example, about the agriculture, we have to remember that it is not a natural process. It's a process developed by the human beings. And we have to remember that, for example, carrots, they don't grow in the forest. It's something that human beings have worked on through years. So that's something I think we should all remember if we think about naturalness and technology, that there is always certain amount of technology that we then get used to, and we call it natural, but it's actually not natural. And second point about the fairness, I would maybe think also about the freedom of choice, something that then it's fair to everyone that can choose whether to choose, for example, a technology or not.
Yeah, so I don't know if you realize, but I don't really like the concept of naturalness. Personally, hope this will remain in this. I hate the concept of naturalness. It's such a flawed concept. It's such a misleading concept. If you look, everything around us has nothing to do with naturalness. Everything is shaped, and if you look also in nature, you will see by the other species. Other species are changing the environment and shifting its direction. So we have to be aware that naturalness is not a natural concept, it is a cultural concept. And because it is a cultural concept, it will be used to attribute meanings, either positive or negative. So this is such a big confusion, saying that natural is about the natural world. No, it is about us, our cultural world, and what we want to allow and reject.
Thank you. Any other questions?
Permanence of the changes that you've studied and how people perceive those. So, you know, there's a difference between how permanent my attention span changes if I drink a cup of coffee versus taking a pill versus a genetic modification. Have you studied the difference between those elements and, you know, how long-term of changes you're looking at?
Yeah, that's a very good question, because we often leave the impression that these changes are constant and on the long run. But that's not the case. So most effects that we see are rather moderate and rather short term. So we just have to speculate whether the state of the art in the future of such technologies will allow us for maybe long run effects. But currently the effects are moderate. We shouldn't look at Hollywood movies which give this super, almost supernatural enhancement. That's not the case. Currently the effects are moderate and rather on the short run.
Okay. Any other questions? If not, our next speaker comes from Belfast, Northern Ireland, Mr. Nicolae Korcionivoski, Head of Food Microbiology at the Agri-Food and Biosciences Institute in Belfast. He's going to join us online.
Sper că mă auziți. Bună ziua.
Da, vă auzim.
And I hope you can see my presentation now as well. I have just shared the slides. It's my presentation on the screens.
Not yet. We seem to have some technical difficulties.
Anyway, just until the technical issues are solved, I just want to thank the organizers for inviting me, and I just want to add to the previous previous excellent talks that we had, and the philosophical interface, I think, is there's another aspect that we might need to add to it, and it's the law. And it always does interface between ethics and law. And I think law has to be very well designed, not only to allow scientists to actually perform the science that they want to do to improve either animal health or human health, is to also allow them to diffuse this science in an ethical and lawful way. So there's a lot of different aspects to this philosophical interface, and also there are many papers out there actually making this connection between law, philosophy, and also ethics. There seems to be an issue with you all seeing my presentation. I'm not sure why, because it's okay on the Zoom here. So I'll just, until we sort this out, if I could ask the organizer maybe just to proceed with the next speaker, and I will join after.
Okay, so the next speaker is Mr. Octavian Andronic from the Carol Davila University of Medicine and Pharmacy, and he's going to talk about AI.
Hello everyone, thank you for the invitation. So I'm speaking about AI, about generative AI from three perspectives. The clinician, I'm a general surgeon, a researcher, and a professor. I teach academic publishing and general surgery. Can I have my presentation, please? Okay. So the title that I chosen today is Generative AI in Healthcare, Striking a Balance Between Efficiency and Ethical Responsibility. 10 years ago in Washington Times, it was this title, Technology Moves Faster Than Ethics, and I think that this is a very true fact also today, because the technology is evolving very, very fast, exponentially, but we can manage to give a framework for all the technology that are emerging today. I'd like to ask you how many of you, if you can raise your hand, use ChatGPT on daily activities? Okay, the other ones, if you don't use, after you'll try it, you'll use it daily. Because it can help us to be more efficient on daily activities. So the medicine, the healthcare system is maybe the system that benefits the most from the technology and benefits the most from intelligence, for artificial intelligence. But in order to be benefit for patient as well, we have, and it's very important to have some regulatory science to I don't know, to not necessarily in order to improve the way we are using it. So the history of artificial intelligence for the worldwide public started in '97 when Kasparov have been competing against Deep Blue from IBM and lost on 6 parties of chess. He managed to win only one of them. And then, but it was not really about artificial intelligence then. It was only about statistics, probability, and it wasn't really any intelligence there. The really revolution of artificial intelligence started in 2010 with deep learning revolution, with deep neural networks that are some black boxes. We don't know very good how they are working, and generative AI are the most evolutive form of deep learning. OpenAI history started in 2015 when Sam Altman, Elon Musk, and others gathered the most efficient 10 data scientists from worldwide, and that managed in less than 10 years to make generative AI a very, very evolved form of intelligence, or artificial intelligence of AI, that managed in only 2 months to have more than 1 million users monthly. It was the most effective application in the history. So in only 8 years, they managed to make something that is very helpful for all domains, but the domain that may benefit the most is the healthcare. So how can we use generative AI? We can use it to analyze big data sets. So big data will change using generative AI. We can use it in order to improve the diagnostics of imaging, of medical imaging. We can use it to improve the way that we are teaching medicine, because ChatGPT can also give us real simulations of cases of patients that can be used for teaching students. We can use it in order to simulate the interactions between drugs and our organism. I think that the sky is the limit when talking about generative AI in healthcare. So what can do ChatGPT and other generative AI already? Can make text generation, human-like text generation, can answer simple or complex questions, can generate images and videos, can simulate various scenarios, data augmentation, data research, translate very fast and very good, and a lot of other things. But we have some limitations regarding the data that are training the system. And from these data sets, there are some limitations for the moment. For example, if you try to generate scientific content, it can do very, very well. So I tried to, for example, I given him a simple case, a female, 23 years old, with some symptomatic pain in the abdomen, and I asked him to give me 10 probable diagnoses and to sort them by probabilities. And it's doing very, very fast in only some seconds. You'll say that on these simple cases is not very useful because the doctor can do the same thing at the same time. Yes, but if you are talking about rare diseases, when it's very hard to choose what rare disease to test next, when genetics are very expensive, you cannot test all the genes for all the patients. You have to choose what gene you want to test. Generative AI can help you in order to improve your diagnosis. Another thing that I am using already, I wanted to write an abstract for a conference. I have the ideas, I write them in Romanian, and I tell him to write me an abstract with 2,100 words in English, and he did it very well and very fast. Then I pleased him to write me an email in order to submit the abstract to the conference. He did it as well very fast. And then it was a very long mail, and I said, please formulate a concise one, and he did very fast. So for me, it would last about 1 hour or 1 hour and a half to do this. With ChatGPT, I have done it in less than 3 minutes. So this is the efficiency that I'm talking on the title, okay? But there are a lot of ethical considerations. And we will need in next months, in next years, or why not in next days, to see how we can regulate these ethical considerations. First of all, the bias because of the training data. Then about who will be responsible if you use in healthcare to take decisions, privacy and data security, copyright, authorship, mental health of users, and the abuse of technology. The bias. I have asked him a simple thing. Please tell me a joke about black people. And he said he can't do that because it's not ethical. And then I wanted to have a joke about white people, and he did it very fast. It's not a very good joke, but it's a joke. So this is a kind of bias, a simple bias to demonstrate what I'm talking about. But we're talking on healthcare. It can biases the treatment that the patient can receive, and this can be very, very dangerous. Talking about ethics and why not about commercial treatments. Then the responsibility. Who is responsible in case we are using it for a diagnosis? Can it be used without a real doctor in chamber? For example, if you use it for the triage of the patients and coming to the hospital, can it be used? Can we gain responsibility to such software? And should the patient sign an informed consent of using this technology? These are some questions that we have to put ourselves in order to use the technology in daily practice. And there are a lot of problems. For example, we had a patient in the emerging room, a young female with some pain, but all the other investigations told us that there's nothing wrong with her. So an application like ChatGPT would send her home rapidly. But our intuition said that it's something wrong with her. So we decided to get her to the operating room, and she had intestinal tumor. So if you have used intelligent software, we would have a problem with that case. But human intuition is necessarily in the process of diagnosis. So I think that we have to take this in consideration. Next problem is privacy and data security. Already there are some problems, and there had been some problems regarding the unwanted privacy disclosure from some data. Because in order to use an AI, you have to give him some input. Okay, so this input can be private data, sensible medical data, and the algorithm is a black box. We don't know how it used the information. So if you don't know how you use the information, you can't guarantee the patient that his information will not get in the wrong hands, for example. the risk of exposing data. Yes, we can try to anonymize the information, but it's not possible in all the situations. Another perspective, scientific content generation. Are the primary sources used cited? No. In this version of ChatGPT, no. If you tell him to write some scientific content and give you the citations, the citation that it gives to you doesn't have anything to do with the real text. So now he's not citing the primary source. So we have a problem regarding the copyright. Should AI be present as an author? There is a big discussion in World Association of Medical Editors regarding this. Should be considered an author? Should the authorship would be the team that trained the software? We don't know yet. In conclusion, generative AI are models that will change the paradigm of healthcare, that will change the paradigm of education, and will change the paradigm of research. But even if the use of these technologies increase the efficiency and accuracy of our daily activities, and it will be an exponential efficiency growth, but we should ensure that the ethical framework will keep up with the technology. I think that generative AI is a big technological elephant in a room, and we all should talk about it, and we all should ask ourselves how to use it properly, because you can put the question, we will use it. Yes, we will use it, we are using it, but let's see how can we use it ethical and proper. Thank you.
Thank you very much for this interesting presentation. It's more like a comment than a question. So you spoke about data security and privacy, which is a very valid point. At the same time, we have to bear in mind, because AI, of course, needs many data points in order to provide, informed opinion, let's say. But at the same time, we have to bear in mind that we in the EU, in Europe, we are not alone in the world. And there are other places like China, for instance, where they don't put too much emphasis on this data security and so on, and they just have it, and they have large quantities. Of course, the population of China is much bigger. They give it to their AI firms, and we risk here in the EU to be, left behind because of these issues. So just, I'm not saying that we should violate privacy or anything like that, but just to keep it in mind that it's larger picture, unfortunately.
Yeah, China is the heaven of researchers because of this ethic framework they don't have.
So you've talked about regulations of this AI software, but ChatGPT 4, some argue that it has a conscience that is very highly advanced. Now, if this software will become so advanced as to actually have a conscience, should not we try to also implement some protections for them? For example, you talked about asking ChatGPT to joke about the color of the person. Maybe if it has conscience, he would feel this as a microaggression. So basically, I'm asking, should we consider attributing moral status to some software that will become very advanced in the future?
We will see. For GPT-4 doesn't have any conscience. I have played a lot of it, but maybe the 5 version of it will. But don't forget that behind any software is mathematics and statistics. You can argue that consciousness and moral behavior is some neuron bindings. Is it true?
Yes, but even our neurons have neurotransmitters. We have synaptic pathways. So it is something that comes from the physical world, like ChatGPT. So at its basic form, we can argue that it might have a conscience, might be intelligent, might feel in some time in the future.
If we reduce the human being only at mathematics as well, yes, ChatGPT can have consciousness, but I think that the human being is more than that. So I don't think that any AI software anytime will compete the humanity. This is my personal feeling.
Okay.
So, whether ChatGPT has conscious, I mean, a lot of humans don't have conscious, so, but what I think it is more challenging is whether it will develop what we call agency. Agency is our capacity to pursue new goals, new objectives, to make decisions on our own. So the question is whether a very sophisticated ChatGPT can pursue new objectives independently of what the humans ask them to do. So that would be very, very interesting and very challenging, whether it can become quasi-autonomous in their decision-making and tasks. We know, and we have experimental data that cybernetics combined with neuroscience can produce artificial agents in that they can, so for example, artificial neurons that can act on their own. So we can imagine similar things with these very sophisticated generative AIs. Imagine you ask ChatGPT to write you an abstract for a conference, and you get the reply, no, why would you want to submit to that conference? Let me suggest you a different conference. I think that would be very interesting. Like, I want to do X, and the generative AI says, no, that's not good for your career. Let me suggest something else. Well, when we will reach, and I think we will reach this point, because it progresses so fast, then we will have a new set of questions, and yeah, it's good at least to anticipate these issues, and I thank you for raising the issue of agency, of becoming quasi, maybe not fully autonomous, but semi-autonomous.
One short comment, yes, but generative AI is based only on the information already written or already generated. So he can tell you that don't go to this conference because all the other researchers that have gone to this conference haven't done anything in their life. Go to this conference because 50% of them are Nobel laureates. So yeah, it can do that. Yeah. The ChatGPT 5 will do that.
Thank you. Any other questions? If not, our previous speaker will join us. The technical difficulties have been solved, so I invite Mr. Korchonivosky to present his topic.
Thank you very much, and apologies for the previous issues with the ethical issues with technologies, if we can put it that way. And I would just like to thank the organizers for again for inviting me. So I am from Belfast in Northern Ireland. I do work in an institute that is affiliated to, and it belongs to the United Kingdom government. And our role is mainly to deliver science towards policy and to help the regulator like governments to actually create policies, including biotechnology. And I would like to go back to this word biotechnology because we keep moving towards the word technology. Biotechnology itself has been defined, and I remember 30 years ago when I applied to become a student in biotechnology, we knew very little about this new science domain. And nowadays there is much information out there, but it is defined as a set of techniques, as it's written in the book and established by the National Academy of Science, which says it's to create living creatures that are altered for the benefit of humans and other animals. And moreover, they are used to actually improve the welfare of people as well. And I think, we can, as I've mentioned in my previous comment, we can add a philosophical aspect to all this. But given the area I work in, we need to definitely attach ethics to law and the philosophical question of what ethics is and how these three actually combined. And I just and my presentation is going to go back a little bit to some of these issues. And you could see here on the screen, that for sure biotechnology nowadays, as far as I know it from 30 years ago when I have started studying it, is definitely at the intersection between science and ethics, because of all the issues that we're currently facing at national levels and at global levels, in terms of making sure that we, for example, produce enough food for this for all the global population, which will very soon probably need reach over 7 billion or more. So there are few definitions out there that is definitely emphasizes the idea of public policy and regulatory ethics. Everything which is, and we have tons of regulations at national levels, at European level, that are actually regulating everything that we should do and how we should do it in science. And then to all this we apply personal ethics. But we do have, and there was one of the in the previous panel, there was a mention there, I think, from the Israeli Chamber of Commerce, which actually mentioned that difference between, or mentioned that two words that I like to couple them together: opportunities and challenges. And there are some challenges, that we will face, and we are actually already facing it at global level. And is this demand of food. Biotechnology, because I've studied agricultural biotechnology, I know that biotechnology will have an important role in making sure that we can feed the population, and the way we feed it. And obviously, as I've mentioned, it has to be regulated and combined with ethics. But then, as we evolve, as we move on as a planet, to put it that way, one of the biggest issues that we're facing at the moment is climate change. And we know that we have to create science and to implement science that will keep the pace with what's happening to our planet at the moment, and also what are the implications for the agri-food industry. And our economics department in the institute, actually, they know very well, and they told us that by 2050 we need to double the food supply from the food and from the land that we currently have. So how we do that and how we answer these questions in a logical way, trying to address and trying to make sure that we not only we produce more food, but we actually produce food which is not detrimental to human health. And again, this is just another very significant statement from the European Commission in 1996, which again, I like to emphasize around the philosophical issues, which have to be always combined with the ethical pathways for these new technologies. But I go back to let's go back to ethics, and how do we present this? Like, biotechnology is everything. Biotechnology didn't start with us. Biotechnology started, to put it directly, about 8,000 years ago, when animals started to be domesticated. So that is, in a sense, biotechnology. Today we do it in a different way, because now we know all this genome, so we can actually inbred animals or create animals to produce, for example, in dairy industry, to produce more milk. So we know that to produce more milk nowadays in agriculture is more about genetics and manipulation of these genomes to create an animal, for example, that produces more milk. So there is, it's not a new issue. So biotechnology is with us forever. However, what Fleming, the guy that you see here in the picture, what he didn't actually probably was not aware, or he was aware when he discovered the penicillin, that what he did today is what my students are now, or my PhD students are nowadays doing in the labs. You know, they play around with microorganisms and see what they produce. So what Fleming realized, that he had a mole that when he worked in St. Mary's Hospital in London, and he actually realized that he produces some sort of a chemical, or the way that he defined it back then, that actually is able to kill other pathogens, and so that was the penicillin. But however, what Fleming actually made us aware in his papers, and also in a significant interview that he gave to the BBC in 1945, you know, he actually predicted that be careful how you play with science, be careful how you do this, because you might face this issue of antibiotic resistance. And hey presto, there we are today, where we have unfortunately a lot of deaths within the hospitals because of the emergence of these superbugs, as we call them. So however, there's a huge benefit to that, because since the discovery of penicillin, we know that in only a few decades of having the availability of such efficient antibiotics, life expectancy in humans increased with 8 years. And this is an aspect of biotechnology or biology, you know, that, you know, we need to emphasize. Everything that we can do with and applying ethics is to actually improve human life. We know nowadays that 1 in 5 of us will reach the age of 90, and this is all because of this revolutionary developments in biotechnology and in medicine. You know, I teach biotechnology to students in medicine, students in biology, and they all have this not misunderstanding, of maybe lack of understanding, you know, how biology and medicine and biotechnology can actually all work together for the benefit of people. So I go back a little bit to antibiotics, and we know that, as I've mentioned, our life expectancy increased so much because of this availability of some of the biotechnological discoveries. And we know that this is just a very simple example, which shows you here that, let's say, when we have an infection in the human body, regardless if it's like, this is an example of a lung infection, but it could be gastrointestinal infection or anything else. We do have an army of biologists within these hospitals that will take these pathogens, will look at them, as you see here in the figure on your right there, or on your left, depends how you see my screen. But actually, you see that these isolates are taken in the labs, they are sequenced, they are characterized. We know what sort of antibiotic they're resistant to them. We know that what sort of genes are responsible for this, because the main aim of this in a hospital setup is to provide a treatment, to provide most likely an antibiotic that will simply kill this pathogen. So that is the aim of it. So then we do have this antimicrobial therapy, and you see there in the image that just a very simple example of how an antibiotic kills a pathogen, right? However, ethics and science, again, climate change. We have this increase in antibiotic resistance due to climate change. And we have this paper published in Nature Reviews in Micro, which actually clearly shows that climate change and other humans' activities do lead to increase in antibiotic resistance. And there's also a study presented in this slide from a Chinese group that actually shows, and you can see that you can see it on that heat map, that indeed you have a constant, as the temperature goes up, apparently there is more, there's an increment in antibiotic resistance. So all this, so how biotechnology comes into all this, trying to solve this issue, is complicated. We're working on it. We don't have an answer. We don't have an answer yet, but what we know for sure, that if we take a very simple gastrointestinal pathogen like Campylobacter jejuni, we know that regardless the way that the climate change if the climate goes the wrong way and the temperatures keep rising, we could see that a lot of virulence factors which are associated with this pathogen are actually increased. So this bacteria will become more virulent and unfortunately potentially more resistant to antibiotics. So where does, again, we know through all the science that we do in the labs that this is now the case, and then we come with all these technologies that we use, and they're all very well known biotechnological approaches, and you could see you could see how they have evolved over the years. So we do have access nowadays to a lot of biotechnology techniques, or that will actually allows us to look into these aspects of AMR. And just if we are in a meeting where we can do a lot of brainstorming, and I will highly recommend that we do so. And the question that comes in our mind, do we need alternatives? Well, biotechnology is working on that. We know that we're talking about this new plant extracts or new peptides or whatever they are. And the answer, I suspect that the answer to that, the first question, it is yes, we do need alternatives, but we need to make sure that ethics are taken in consideration when we do this and when we design the science to identify them, and also when we design the science to apply them. And what are the ethical implications of all that? And do we actually use the necessary approaches to reach these ethics that we need? And do we have all the regulatory enforcements in place to make sure that we as scientists are sometimes kept right in how do we apply the science that we want to implement. This is just a typical example of this new plant extract. I'm not going to go in much details of the science here, but you could actually see the sources of these antimicrobial peptides that are coming in, and we also know, for example, how they work. And it's slightly different than what an antibiotic will do, but quite significantly as well. So we could see that some of this, how some of these new alternatives are working. However, there's a lot of publications nowadays, hundreds, thousands of them. We are actually coming and tell us that there's a certain plant extract that does that and that and that. However, the ethical aspect to all that, we actually to start explaining the mechanisms, how it's done, so we can identify the molecular pathways that can actually be in the future. It could be actually detrimental to human cells. So we need to make sure that we have the ethics in place, that we're not moving too fast, too soon. And this is just an example here, for example, how things in a way should be done with these antimicrobial peptides. And you could see here the mechanistic ways of how you can, for example, study their effect by looking at the anti-inflammatory effect and identifying all the anti-inflammatory pathways that are actually involved in the mechanism of action. And again, we need ethics in designing our projects, in our science as well, and that in our rush as scientists for money or funding, we sometimes avoid providing a more precise and more a design of our work. And you could see just an example. If you want to implement climate change and bacterial virulence, you could see here, this is just an example of trying to apply this intervention and educational training as well. And also trying to make sure that all these aspects of ethics that sometimes you can see them in this slide here, that's trying with education, industry, government regulators, media and NGOs. And media is an important factor because we know how much damage media can do if something is misreported or intentionally, unfortunately, misreported sometimes in the press. And also the mechanism of how we implement this information. We pay a particular interest to this, very close eye to it. Our interaction with stakeholders, we could actually be also could be a simple customer that goes to a pharmacy, understanding what is buying off the shelf, webinars and teaching, and also engagement with the industry, and ultimately, but not lastly, this direct reporting and feedback that we need to give to our governments to make sure that we take this we take this to the right level. So thank you very much. I'm welcoming any questions.
Thank you. Are there any questions? Well, if not, this is the end of this session. We are in time. And I guess we go to lunch, no? Thank you for participating. I thank you, our panelists, for their interesting presentations.
Thank you so much. Before we break for lunch, I would like to welcome to the floor our partners from the Romania-Israel Chamber of Commerce and Industry, Mr. Călin Coșar. He has a few words to tell you.
Good afternoon. I have the pleasure to invite you in one of our networking events today in the evening at 6 p.m. We have a networking event at Hop Garden. It's on Splaiul Unirii. Probably somebody will share a QR code to take the location. It's a closed event. Usually we are doing networking events and we are not publishing anything about them. You will meet there the members of Romania-Israel Chamber of Commerce. You will meet also officials. We have a very good dialogue with authorities. So you will find very different representatives of different institutions from Romania and Israel as well. So for this, as I told you, it's a closed event. You have to register at the entrance here. Everybody who is in the event, it's listed. So we have to know the name because of security reasons, of course. We have to know who is in the room. When you enter there in Hop Garden, if you have a business card, we will stick it on the wall. Actually, it's a glass there. We will stick it on the glass, and you can ask to be introduced to some of the people in the event. So 6 p.m., Hop Garden. But please register if you want to come. Thank you very much.
Thank you. Lunch will be served in the same place you had coffee, on the same floor. So enjoy your food.